Okay, in this video we're looking at Unit 5B, determining whether we should believe a statistical study. And in this unit there's not going to be a lot of calculations going on. We're going to be looking at a lot of hypotheticals or surveys that have happened and trying to interpret whether or not what we see we should believe it at face value, or if we should have some uncertainty. And here are some of the steps, kind of the guidelines that we'll outline here for evaluating. First is to get a big picture view of the study. So you should be able to understand the goal of the study, the population that was being studied, and whether it was observational or an experiment. So those things should be evident to you kind of in your first analysis. You should be able to get a big picture idea of the study. Next is the source. We want to look for potential sources of bias on the part of researchers, and we're going to talk about different kinds of bias here a little bit later on. But is there a hidden agenda, or if just an example of bias is if someone says something along the lines of, watching TV will make you die sooner, or something like that, where it's a pretty bold, broad statement. And if the source is, wehatetv.org, there may be some bias there. So those are things we're going to be looking at when we talk about the consideration of source. Then we want to look for bias in the sample. We want to decide whether the sampling methods that we discussed in the last lesson, simple, random, stratified, convenient, and systematic, we want to determine whether that sampling method was likely to produce a representative sample. Okay, number 4, we're going to look for problems in defining or measuring the variables of interest. So we're going to talk more about variables here in a minute. But if there's ambiguity in what the variable is and what they are, it can make it really difficult to interpret the results that are there and given. So identifying those variables and how are they defining them, how are they measuring them, those are key things that need to be clearly stated for us to believe the validity of a study that we're looking at. Okay, and then this one, beware of confounding variables. We'll talk about this idea of confounding variables. But if a study neglects to point out, potential confounding variables, and again we'll talk about that, its results may not be valid. It doesn't necessarily mean it will be, but it can definitely diminish or bring down that validity level. Okay, we also want to consider the setting and the wording of the survey. So look for anything that might tend to produce an inaccurate or dishonest response. We'll look at a couple examples of that. Check that the results are presented fairly. We want to check whether the study supports the conclusion that are presented if it's in the media or whatever it may be. Make sure that what they say is actually supported in their conclusion. And then we want to stand back and consider the conclusions. Evaluate whether the study achieved its goals. If so, do the conclusions make sense and have a practical significance? Okay, so this, we talk a lot about, do things make sense? And you'll have to make some judgment calls on these. Do they make sense to you? And then be able to back up why they do or why they do not. So a couple of things, like I said, we were going to talk about first was bias, and bias in choosing a sample. Okay, there is one idea called selection bias, and this occurs when researchers select their sample in a way that would tend to make it unrepresentative of the population. And so, for example, if a pre-election poll that surveys only registered Republicans has selection bias because it is unlikely to reflect the opinions of all voters. So if you only pick one political view, then that potentially could sway that poll significantly. And so, if you do it from my standpoint and you say, how many people feel that, what percentage of the population feels that math is essential and very important, and if my only people I selected in my study are math teachers, then obviously there's going to be some bias because a certain individual goes into teaching math for various reasons, obviously one of them being they feel the value of math is always there. So that is what we call selection bias, and it occurs when the researcher selects a sample in a way that is unrepresentative of the sample of the population. Now, participation bias, this next one, occurs when people choose whether to participate. So, for example, participants must take action to participate in a survey rather than being selected randomly. Those who feel more strongly about the survey are more likely to participate. We see this in surveys and things on Google all the time, or other places where someone leaves a review, and a lot of times you'll see very positive reviews and very negative reviews, and then the middle is a little bit more sparse. So those who are very passionate are likely going to choose whether they want to participate. And so when you look at surveys or polls in which people choose whether to participate, they're often called self-selected or voluntary response surveys. So when you see those, keep that in mind that you may have some participation bias. Okay, now we're going to talk about this idea of variable. So a variable is any item or quantity that can vary or take on different values. And so we could be looking at a percentage of people who enjoy a certain TV genre, or the number of people who choose to wear a certain type of clothing brand versus another, or so forth. I mean, those are different variables that can take on different values. Now, the variables of interest in a statistical study are the items and quantities that the study seeks to measure. So those in a study, the variables of interest need to be outlined, they need to be defined, and they need to tell us how they're going to measure those variables. Now, in almost any setting, there are variables that are not intended to be a part of a study and can make it difficult to interpret the results properly. These variables are called confounding variables because they confound or confuse a study's results. It is not easy to discover confounding variables. Sometimes they are discovered years after the study was completed, and sometimes they aren't even found at all. We just can't explain all of the variations in the variables, and there are things that we just don't know. But some confounding variables are very obvious and can be discovered simply by thinking hard about the factors that could have influenced a study's result. So if you did a study on whether or not someone enjoyed a certain type of food or a certain restaurant, well, if that person was starving to death, they hadn't eaten in 24 hours, and then someone else comes in having had their regular meals over the last 24 hours, that could be a confounding variable where someone may rate it high because they're so hungry that they just want something to eat, versus someone who is just going to their next meal. So but those confounding variables can be very difficult to identify. If someone claims to know and has identified every confounding variable, that would make us question the study right up front. So those are kind of all these definitions that and things we're going to need to take into account as we try and make some decisions here. So now let's put some studies in front of us, and first we're just going to decide whether each of the following makes sense or whether it does not make sense, and then explain why we feel so. So the first one says, more than 1 million people sent texts in response to a TV survey question. So this survey result is more valid than a survey of a random sample of 200 people. Okay, so here, at least for me, this does not make sense. And a big part of it is there is a lot of potential for that participation bias in the first study. So 1 million people watching the same TV show, and they answer a survey question. Okay, they're obviously invested in that TV show and can carry some bias. Whereas if you randomly select 200 people to answer a survey, that participation bias is much less likely to occur. So that doesn't make sense to make that claim. And we don't know anything about the variables or anything like that, but just to say that since we have 1 million people, it's more viable than 200 people, that participation bias begins to creep in there. Okay, here's another study. My experiment proved that vitamin C reduces the severity of colds because I controlled the experiment for every confounding variable. And right there, as I mentioned before, that does not make sense because being able to control every confounding variable is nearly impossible, especially when you're dealing with humans. Humans have so many variables, it's really hard to control them all and to take into account everything. So just because of that, controlling every confounding variable, that just doesn't make sense at all to make that claim. Okay, this next one, we're going to look at should you believe the study? So based solely on the information given, do you have reason to question the results or the methods used in the following hypothetical studies? And we want to explain why. So a study by the Liberal Center for American Progress is designed to assess a new Republican budget plan. So this one is definitely going to have some questions. So I would say here that you should question this one. So you should question the results. Due to potential bias. Because a liberal center that's evaluating a Republican budget plan, liberals, Republicans tend to have a little bit different views, and they may be a little bit more critical of that budget plan than if you were just to get a random sample of people in America to look at that budget plan. So you should definitely question those results due to some potential bias that could be in there. Okay, this number 15, researchers designed 5 survey questions to determine whether Europeans are more optimistic than Americans. Okay, if that's all the information given, again, we'll say here, okay, you should definitely question the results of this study. That says results, it doesn't look like it. Results. A couple of reasons here. One is, how do they define optimism? And how do they measure it? So if those are that's the only little blurb that you have, you'll definitely want to question that and seek further information as far as how do they define and how do they measure that variable of optimism. Okay, number 16 here, we got a government study is designed to determine the percentage of taxpayers who understate their income based on people who had their tax returns audited. Now, in this one, we're looking at a government study. It tells us its design, what it's trying to do, and it tells us how it's going to do that. It's going to do based on people who had their tax returns audited. So right here, there really isn't a lot to question. So I'm just going to say in this one, there's no obvious reason to question based on the information given. So I'll say the info that's given. Yeah, there's nothing in there that throws out red flags that will make us want to question it based off of that little blurb. Now, if we had more information, it could throw that out there, but there's nothing obvious in that little sentence that they've given us there. So that's looking at trying to determine whether or not we should believe studies, whether they make sense or not make sense, and we'll continue the rest of this in a part 2.